Hello, Artoria. I have a working theory. I am very, very skeptical that the problem, if you go back to what is it, page page 34 of the schematic diagram. I'm very skeptical that the problem has anything to do with C1 or C2. And here is why. C1 and C2 are series circuits to diode rectification. And the diode rectification is high impedance. So I don't really care if the capacitors were dead short, which I know they're not. And I don't care if the capacitors were open, which I'm pretty sure they're not, because there's not a lot in terms of circulating currents going on right there to cause the capacitors to go bad. Having said that, there is still an imbalance in the bridge circuit. So if I bring up the bridge circuit, there we go. There's the bridge circuit. All right. So let me zoom in on the bridge circuit, because this is the area of interest. Right here. Okay. This is the bridge circuit. And from this bridge you end up with alternating current and voltages if the circuit goes out of balance. These resistor values are very critical, extremely critical. Okay? And I have measured all of these. R1 is in fact 180 ohms, R2 is in fact 100 ohms, and R3 and R4 are all 100 ohms. So the combined resistance of R1 and R2 is 64.3 ohms, roughly. Okay? The combined resistance of these two is 64.2 ohms. At 1.8 megahertz, C1 and C2 represent about 880 ohms at the lowest operating frequency. At the highest operating frequency, they represent about 50 ohms. So, yeah, they're making minor adjustments to the DC voltage that it ends up being created at this far end, but really not a lot. Look at the load resistances. 47K, 47,000 ohms, next to 800, between 50 and 800 ohms, very insignificant. The same down here for the SWR detection circuitry. You got 50K ohms that the diodes are creating a DC voltage into on both sides, forward and reflected. It's not there. The AC voltage is appearing here. Why would the AC voltage appear here? Why would the bridge go out of balance? Well, I think it is a capacitor, but I don't think it's the capacitor that I've been looking at originally. I think, hold on, I think it's either this capacitor or this capacitor, C44 or C47. At 1.8 megahertz, the lowest operating frequency, C47 has a reactance of 4 ohms, and C44 has a reactance of approximately 2 ohms. That's at the lowest operating frequency, and it goes down from there. So alternating currents, this bridge needs to see a AC ground reference that's nearly perfect. And if it's not, then that's going to throw the bridge out of balance. And I think that's why some of the other models in the Kenwood line don't have this problem, because on this particular radio, which is unique to the Model 440, I'm pretty sure, okay, this line right here is brought to a 5-volt DC reference. So it's at a 5-volt DC reference, but it needs to be at an AC 0-volt reference. And that's the job of these two capacitors right here. I'm going to be replacing these disc capacitors with polystyrene film capacitors that are extremely low equivalent series resistance. And in fact, I'm going to be bumping up the value on those capacitors just a little bit, which may mean that I might need to retune the bridge just a smidge. We'll see. But I'm going to take those capacitors out and test them, and even if they pass the capacitance check, they still might not pass the ESR check, which I am not able to test. So I don't really know if they would pass the ESR test. Polycapacitors won't be able to carry RF. I disagree. You really think so? They have an extremely low inductance. In fact, the ESR and the inductance values actually polystyrene? Hold on a second. It depends on frequency. I did tests years ago with RF and polystyrene are only good for audio frequencies. Yeah, I was able to read between the lines there. You think so? Boy, I don't know. I'm going to tell you something. I used one of these. Hold on a second. Oops. I used one like this in my linear amplifier for the grid biasing resistor bypass to ground. Okay, this is also a polystyrene or polyester film capacitor. Very good at RF and extremely low ESR. Build two identical circuits on the breadboard and pass RF of the frequency you're using. I wish I had an RF signal generator that would generate 1.8 megahertz. Let's see. This one, however, let me think. 10K times 100 is 1 megahertz. My signal generator will go up to 1 megahertz, so that's about half of the lowest operating frequency. But you know what? I'm going to take your word for it on that one. Because you're pretty sharp in that regard. So, I'll just get the capacitors out that I want to use here. And why do I have electrolytics in this drawer? Because it's 0.1 microfarads. How about that? Alright, so here's a 0.022 brandy new. And 103. That's 0.001. What's that doing in here? That doesn't belong there. Oh no, that's 0.01. Never mind. So I just need now 0.047. You really sure about those polystyrenes? Boy, if that's true, then that might explain a couple of things with my linear amplifier. Let me find an article for you. Okay. I will be happy to read it. As long as it's not too long, because I want to be in and out of here fairly quickly. Man, 0.047s are surprisingly hard to come by here. I think I had more than that. what's this? Hold on. 403Z. That might be close. Got a few of those I can cherry pick. Is that 0.01 or 0.07? That's weird. 16 volts. Yeah, I don't think so. .02 at 100. 0.02 at 50. 0.05 at 50, but it's way too big. There's a 0.05 KCK. I wonder what that. Alright, well, I think I got enough to work with here. Let's see what we get for capacitance readings. Let's see, 20 nanofarads, 2 microfarads is 2,000. 2,000 picofarads is 0.002 microfarads. This is 0.02 microfarads. This is 0.2 microfarads. Right? Full scale. What do you got here? Radio electronics info capacitor types PHP. Alright, let's take a look at this. So polystyrene capacitors are a relatively cheap form of capacitors but offer a close tolerance capacitor where needed. They are tubular in shape, resulting in the fact that the plate dielectric sandwiched is rolled together, but this adds inductance, limiting their frequency response to a few hundred kilohertz. They are generally only available as well, yes, okay. Polyester film capacitors are used where cost is a consideration, as they do not offer a high tolerance. Many polyester film capacitors 5 to 10%, which are adequate for many applications. They are generally only available as leaded electronic components. Okay, but they don't say that a polyester film capacitor is unsuitable for RF. I understand that the tolerance is greater. Polyester dielectric capacitors are based around, polyester capacitors are based around the use of a polyester dielectric. Duh! Polyester dielectric have low ESR, we know this. Bleeded versions only, high dielectric strength. Metallized film and foil. Polyester capacitors use layers, yeah. And they don't mention RF applications. Interesting. Okay. Ceramic. They want ceramic up for RF. Interesting. Okay. Silver mica, of course, for RF. Okay, I digress. Good article. Thank you for sharing. Okay, so that one's actually 0.046. That one is actually 0.030. What are these? 0.01s. 0.1s. No. 0.07. Really lousy tolerance. So that's what they are. Okay. That's 0.033, 0.033, 0.033. So that one's out of the question. And this one is 0.027. That's good. 0.1. Alright, I think I have my two capacitors. I hope this one has enough dielectric strength. That's the only unknown here. There's no rating, no voltage rating on this capacitor. I don't like it when they do that. Wow. I'm going to be very happy if this works. And I should probably get my regular solder sucker for this job because it's a lot of solder to remove, and I'm running out of Chemwick. Which I've had for almost 40 years. Where is it? Here it is. You know, if your Ubuntu virtual machine works so much better than your Windows native machine, it really begs the question, why aren't you using Ubuntu exclusively? Come on, man. What's going on here, you know? What up with that? What up with that? How much more convincing do you need? And I had a razor blade around here somewhere. Crap. Where did I put it? Oh, here it is. Yeah, I think we tend to take for granted and overlook how important these ground bypass capacitors are. If this ends up being the solution, I'm going to be very happy to publish this. Like I said, it would probably be one of my most popular, at least amateur radio videos ever. Because I'm sure I am not alone in my suffering. You will also note that I am not playing any music in the background right now because I have a fairly high degree of confidence that this might actually solve the problem. And I would love to be able to publish this live video without the copyright Nazis striking it down. As it is, the fucking copyright Nazis struck down a live video that I took of a local band concert performance of an Eagles tune. I challenged it, and YouTube upheld the copyright complainant. Fucking bastards. Hey Google, this is for you. Fuck you. It was my friend who was playing that song, and you struck it down. Fuck you. You know, I checked the price. I checked the price on Amazon for this Chemwick because I couldn't find it locally. There's a similar product called Solder Wick, which is absolute crap, and I refuse to buy it. But you can get it on Amazon. Now, granted, I've had this almost forever, and I don't go through it very quickly. And it is good quality. At least I assume they still make good quality. That remains to be seen. But $20? Really? I don't know. So if Adirondacks should happen to show up, he recommended a very good movie to me the other day, and I happened to watch it today, called Upgrade. Pretty decent flick. And as with most sci-fi, there are a couple of problems with the plot, but yeah, you know, you gotta look past those things. I watched all the 12 Monkeys series much better than the movie with Bruce Willis. It had a very good end. I think they tried to make the movie appealing to just by having Bruce in it. When he's Bruce, the series was far more interesting and well made. The actors did an awesome job. You know what series my daughters got involved in and really enjoyed watching on Netflix was Breaking Bad. And apparently it was very well done. I've seen a couple of the episodes with them, and I just have a problem with sensationalizing the drug culture in any form, regardless of how well it was acted, you know, how interesting the plot twists were and all that horse shit. It exposes an underworld that I think is probably best left covered up. An underground culture, you know. I have mixed feelings about it. Alright, so the new capacitors are in. I do not know if they're going to make any difference. I will check the old ones to see if the capacitance value is within tolerance, but that's still not going to tell me anything about the ESR values, which are also important. Oh! Oh. Never mind. Yeah, so 0.043 and 0.021. So the capacitors are intolerance. Almost wants me to look at these other bypass capacitors, C7, 8, and 26. Okay, C7 and C8 are the series coupling capacitors to the diodes for the forward-reverse sensing. Unlikely that's the problem. Although if they were leaky, if either of those was leaky, boy, I wonder. I can certainly check the leakage of the capacitors, because this meter goes up to 2000 mega ohms, which is 2 giga ohms. That one's definitely not leaky. That one is not leaky. I'm going to replace C7 and C8 just because. What's interesting to me is that under normal operating conditions, D1 and D2 are in a forward biased condition. Almost at all times, because the voltages at pins 2 and 3 of J1 4.36 and 4.65 respectively, which is what you would expect for the voltage drops. And then 5.66 and 5.7 in transmit. The DC bias plus the AC rectified. Be interesting to see what those change to. But yeah, I'm going to replace C7 and C8 just because. Just because I have it open. I changed C44 and C47. C44 is the bypass capacitor for pin 4 of J1 on the right hand side. If you're looking at it from my perspective, I'll point it out. C44 is right here, and C47 is right here. Those are the two bypass capacitors I have already changed, and I'm now going to change C7 and C8 right here, because a tiny amount of leakage on either of these capacitors could definitely cause a problem. Lynn, shut up. I don't know if you hear the dog barking. That dog's getting under my skin. And this tip very hard to keep tinned. No, actually it's a Weller WTCP. Old school. The temperature control is with a magnetic switch. You can hear it in the handle going click, 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 click. The temperature is regulated by your selection of the tip. There's a number stamped on the back of the tip. 6, 7, or 8. Those are your choices. 600, 700, 800 degrees. I think most of mine are 7s. I don't have any 8s. Yeah, they're all 7s. And no, it's not neat. It's archaic, actually. The contacts in the handles, in the wand, are what go bad most of the time on these soldering irons. because they arc and they tend to build up resistance. And then one day it tries to close contact, and there's nothing there. And there's enough carbon on the contacts to generate heat, and it burns itself out. And you're looking for a new wand. Well, I've been through a couple already. They're kind of a pain in the ass. I would much rather have something electronically regulated. Okay. It's the moment of truth. What is J7? What is J7? Why are we sending RF all the way over here? This is the 50-watt jumper. That no one ever uses. And what time is it? Almost 6 o'clock. All right. I've got just enough time to put this back together and test it before dinner. I'll put these capacitors aside. These are the ones that came from my parts drawer. I can't wait either. I'm excited. And it's probably going to flop. But, you know, you take your shot. Let's see what happens. All right. It's 5:57 and 22 seconds. Here we go. Clock is running. Let's see how quick I can get this bag in here. Once I crack this, you mean if I crack this? And stop. Less than 2 minutes. Actually, just over 2 minutes. About 2 minutes and 10 seconds. 2:15. That is not something I really wish to be proud of, you know? Okay, here goes nothing. Power supply is on. I did connect my RF jumper, so we're good. Didn't forget about that. Rig is on. 7.1 megahertz. Amplitude modulation. Meter is on 100 watts forward. Survey says exactly the same forward power. Fuck me. Exactly the same forward power and a pegged SWR meter. I said I was going to call Kenwood today. I didn't, but I sure as shit will tomorrow. Fuck. Well, I guess these capacitors are good. I can throw these back in the parts drawer, okay? Yeah. There you go. Recycled. Yeah, like Thomas Edison, I found one of the thousands. I succeeded at finding one of the thousands of ways that did not work. Yeah. Not that I want to be compared to Thomas Edison because he's a fraud, but that's a whole nother story. I'm leaving. Goodbye.